Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Seth's brother Joel. We're here to hopefully show you how to approach SAT math questions. So today's the day that we are going to constantly being referred back to, because today we're going to make a little change in what we do. We're going to start going over the con practice, but on the digital side. Anyone taking the SAT in the United States after 2024 will be taking the SAT digitally. I think that's actually happening to the international people now. And Khan gives you practice on the digital for the digital questions. You can also download this thing called Blue Book and actually take practice digital SATs, which is highly encouraged. You get 4 of them. You should do that. Maybe one day we'll show you how to do that, but you could sort of go on the website and follow this, you'll find. But what we will do is we will show you how to get to the Khan digital SAT practice. It looks different and has a different feel than the other SAT practice for the non-digital test. So what you do is log into College Board using your account. You type in, doing a search bar, digital SAT practice Khan. And you get all these different things. Here it is. Digital SAT practice and preparation. Good. Okay, so what have you got? Oh, Khan Academy. Very nice. Go to Khan Academy. Here we are. Let's go. Okay, let's go. Okay, here we are. So this is the Khan Academy side on the digital. They break it up into 3 different sections as opposed to 4 different sections of foundations, medium, and advanced as opposed to 4 levels. And in each level, like algebra, you will get a bunch of topics very similar to the other Khan. What we will do is we will only focus on the advanced questions so that if we do the concepts, because we're big into concepts, understanding what you're doing, presumably if we understand the advanced, then you could do the other ones, but you should do the other ones too. Okay, so let's get going. Okay, so should we start with the first one today? Why not? They even give you a lesson, which is nice. They give you a basic example, and we get a practice. Solving linear equations and inequalities advanced. Here we go. So this is our question of the day. We have to wait for it to come up. Okay, now we only get 4 questions, but after you finish those 4 questions, it's going to say, do you want to retake this level? Yes, and you've had, I think it's about 5 iterations before the questions repeat, and some of these questions are on the non-digital side. But anyway, so we basically have 20 questions per topic, so we have a lot to cover. Let's go. Here we go. Here's our first question. Okay. If 1/2 plus 4x is negative x plus 2, what is the value of x? So, Seth would say just follow your nose, right? And just solve for x.
Yeah.
Yeah. So, well, let's see. Let's annotate. We have a nice thing there. So what does that mean? That means to add an x to both sides to get the x isolated. So you get 5x plus a half.
Why bother with 5x? No, you need, okay, there you go. Yeah, good.
5x plus a half is equal to 2.
Yeah.
Right? So you might as well do 5x is equal to 1 3 halves. We subtracted a half from 2. 2 minus a half. $2 minus 50 cents is $1.50. Oh, then Seth's not going to want me to cross multiply. But anyway, why don't we just divide by 5?
That's 3/10.
Why don't we just divide by 5, right? So x is 3/10. So x is 3/10. Plain, simple way of doing it. You could have cleared the fraction. You could have multiplied everything by 2. But that may be a little dangerous. What do you think, Seth?
Well, I like the way you did it.
Yeah, it's very conceptual in that the approach is the simple approach, which is isolate x, get x by itself as quickly as you can. And that's the way to solve linear algebraic equations. So, wow, there's really not much to this one, which is fine because today's Throwback Thursday.
Should we go to another? Should we just do the next one?
Should we?
Yeah,
Okay. I mean, wow, this is the
one more.
advanced. This is the advanced, but that would mean that the simpler
Yeah.
ones are really simple. Okay, so that's 3/10. Check. Wow, look at that. We get it right. Or we agree with them. Let's see how they do it. Oh, oh, they don't. They don't really. They don't. Wait, no, they do. Oh, they don't really describe how to do it if you get it right. But I think they do. But I don't see it.
Well, it describes a mistaken step, right? But they don't. It's not in the context of the steps that it's a part of. You see, they give the incorrect
Yeah,
answers.
right. No, there is a way to do it. Oh, so let me make big screen just for a second. Um, Let me make us small just for a second, just to see where it is. I know there's a way to see how to do it, even if you get it right.
Then it
There it is.
says
Way
a
to
step
go.
by
See,
step solution.
see, it says way to go. See a step-by-step solution. Okay.
Oh, yeah.
So now we have to do this because we want to have this a human experience. So we want to have our. Where are we? Here we are. Okay, we're back. Hello, everyone. So this is the step-by-step solution. Okay. Oh wow, look at that. This time they give you the steps. 1 of 5, 2 of 5, 3 of 5, 4 of 5, 5 of 5. That's a little new. Okay. 1.
What?
We can find the value of x by first isolating the x term, then getting rid of the coefficient of x. Wow, so this is good. They're starting to show an approach now, as opposed to the other answers. Oh, wait. Since we're adding and subtracting fractions, we need to rewrite the terms so they have a common denominator. But not yet.
Not yet, no.
Not yet. Not yet. Okay, let's
Yeah,
isolate the
that's
x
silly.
term. Wait, what are they doing? Why are they? What are they
They're
doing?
they are
Oh, I see what they're doing.
putting the fractions in a common denominator before they're beginning any of the subtractions,
No, but
which
this
you
is a
don't
little
need to do.
strange. This is a little strange. I mean, no, it's not a little strange. It's not a little strange. Adding the x to both sides. They're showing
Yeah,
more
add the
detail than
exponents to
they.
both sides, sure, but
Yeah,
why bother with the half and the two at
right,
this point?
right. That's right. Yeah, that's
You
not.
know, what
That's
we did
going.
was simply derive, we dealt with the monomial terms and the
Right,
constant terms separately.
right, right,
And we
right,
didn't
right.
have to mess with mixing them up.
Yeah, I can't believe anyone would actually do this. I can't believe anyone would actually do this first as you're doing the x. It's a little
Yeah.
strange to see the x written very, very horizontally. You don't normally
Yeah.
do that. Usually do 4x plus x vertical.
Yeah. Yeah.
But I guess for the reasons of typesetting, they wanted to do that. So now you do this. Now this is so strange, right? They're showing more
Yeah.
steps than they used to. So now, okay, finally we get rid of. Look at that. Look at their casual way of talking. Get rid of. That's not very mathematical, is it, Seth?
No.
First, we can get rid of coefficient 5 by multiplying both sides of the equation by its reciprocal. Okay, whatever. Yeah. Okay,
Well, you
great.
could get rid of coefficient 5 by multiplying one side by its reciprocal. You'll get rid of it, but you'll change the interpretation of the equation. You'll produce an equation that's not equivalent to the original, but you'll still get rid of it.
Yeah. Yeah, the descriptions, the wording is not that precise. Yeah, then you would really want to say that the reason why you do that is because you have to do whatever you do to one side of an algebraic equation, you
Yeah.
have to do to the other side of an algebraic.
You have to keep the equation balanced.
Right. Yeah.
You have to maintain the logical equivalence of
Yeah.
the new equation and the old equation.
You know, be
That
interesting.
one,
Yeah. No, go ahead.
ah,
You know, be interesting. because there are some questions that are both on the old and the new in the con practice. Hit a question that was on the old con and see how they answered it, and then watch the digital side, because the answers feel very different on this side, don't they?
Mm.
They're much more well worked out. So what are you in the mood for? Should we just move to question
Yeah, let's do one more
Okay,
question.
Seth's in the mood.
Yeah.
Okay.
And then
Ooh,
move on
inequality. Ooh, look at this.
Oh.
Okay. Which of the now you only get 4 questions here. If you're practicing for the SAT, strongly advise just don't do 4 questions. I mean, if you're doing this, do at least 10 by repeating some of the by just saying, "Oh, let me try more on this level." Okay, which of the following best describes this? What? Which of the following best describes the solutions to the inequality? So, what a weird way to ask that. Isn't that strange? Which of the following best describes the solutions to the inequality? It's a strange way of saying.
Well, some of them might describe subsets of these solutions.
Oh, right. Got it. Now I hate this one because oh no, it's not that bad. It's not that bad. You don't really ever want the X on the left side, do you? No, the right side. You never want the X on the right side. You always want it on the left side. So
we'd like to have the coefficient of X be positive.
And on the right. Well, you have to have
doesn't matter because they gave you the choices, for the 2 of the choices are X greater than or equal, and 2 are X less than or equal.
Right.
Well, whatever the answer is, it will be of the form an X on one side, coefficient 1, and either a greater than or equal or less than or equal. Right?
Right.
So rather than worrying about which side the X is on, you need to get on the equation, the inequality, you need to get the X on some side of the given inequality where and make the coefficient of X be 1.
Of course. Right.
And now, so we don't want to get the coefficient to be a negative number, because then you have to switch it, which entails switching the direction of the inequality, a spot for a mistake.
That's right.
So, what Joel did was subtract 3x from both sides.
Yep.
Very good.
Thank you.
Getting the inequality is equivalent to 16x plus 1 is greater than or equal to 0.
Yep.
Right? Then subtract the 1 from both sides and get 16 of x. 16x is greater than or equal to negative 1. Then divide both sides by positive number 16, preserving the sense of the inequality, and we get an inequality that matches choice D.
Right. Yeah.
So the inequality that is equivalent to the given inequality, that inequality is exactly one of the choices, and so that choice is the best description of the solution.
Right. Yep. If you want to do a very quick check, particularly when you're not doing SAT, you can always check 0. Does 0 work? 0 is in the set, and 0 works. Right. 1 is greater than or equal to 0. Okay. Not much to say here. It's very similar. You want to isolate, but you have to be a little careful because you've got to get that X on the left side, and you're lucky that it was a positive once you do that. So
you said left because the choices have the X on the left.
Right. Yeah. Thankfully, because my brain freaks out when X is on the right. I don't know about you, but it's hard for me to understand this. It's hard for me to understand 3 is greater than X. I can't handle that. I got to do X is less than 3. I don't know. It's me. Okay.
Well, what if the inequality? You have 2 inequalities that confine X to an interval.
You want to know something? It took me. I was in engineering school for almost an entire year. it took me almost a whole year to figure out that x less than 3 less than -2 is a number between -2 and -3. Yeah, it took me a
Oh,
while
poor
to figure
Joe.
that out. I know. Now I know it. Now I know it. Now I know it. But
Now you know
but
it.
on this side, if you do x is greater than or equal to 4, greater than or equal to 3, I still am not quite so sure what that is. I'd have to break it up and figure it out. But let's not do that.
Well, that's impossible.
Right. Oh, okay. So, yeah, you'd have to break it up. Well, then, wait, that means you go. Is that possible?
Yeah, 5 is greater than or equal to 4, and X can be in between.
So, in other words, this is the same. Wait, is this the same as x is less than or equal to 5, less than or equal to 4? Are these the same?
Allow me to use my eyeballs. Yes, yes.
Wow. Okay. Yeah, okay. Okay. I would have to, like, sit there and
But
prove
the
that
one
to
you
myself.
crossed out
Yeah, yeah, forget it. It's
says that
impossible.
3 is,
Yeah, yeah, yeah.
yeah.
Okay, so I guess that's it. Oh no, let's look. Always fun to look at the answers. Now let's see if they have the thing on the bottom. No, this is so annoying, right? In order to see the thing, well, actually, let's try and get a hint for this problem. Ooh, so you
Oh,
see,
there we go.
then we could just keep going, right? Get another hint. So this is the
Yeah.
answer. So let's just keep doing this rather than change screens, which annoys everyone. This only has 4 steps. First, let's subtract 3x from both sides. Very nice. Now let's subtract 1 from both sides. Very nice. Finally, divide this. 6 is x since 16 is positive. Inequality, Seth said that himself, and that's it. Okay, great. So we've done the first 2 on the advanced. Okay, so I guess that's it for that. So should we try today's Throwback Thursday, which is when we take a question from a pre-2016 test when the SATs were somewhat more of a reasoning test, and we see that to compare the different SATs, and they change over time. So let us go here. Oh, here it is. Very nice. Very nice. Seth, we're sharing screen, and do you still see it?
I see this Khan Academy screen.
Oh, you don't see the Throwback Thursday question yet?
I think you need to do is unshare the screen and then share again with the right window.
Yep, I think so. How about now?
Oh, that's different. Yeah.
Now
okay.
You see it. Okay, Throwback Thursday has begun. High point of the week. Okay, here we go. Oh wait, we did this. This is not the one. I think we did this one already, didn't we? Oh no.
I think we did one like it. I don't think we did this one. A good one.
Yeah. Okay. I thought we did that one already. But it is a good one.
I don't think we did that particular one.
Well, okay. So which
one? This is a more interesting one.
Okay. Yeah. Why don't we do this one? Okay. Oh, I thought we did that one already. Okay. Maybe we'll do that next Thursday. Something to look forward to. Okay. Here we are. Wow. Right. I think we're set. Oops. I want to be on the Zoom. Okay. Great. And Seth, you can annotate, right?
Oh wow!
If Seth's thinking, not a good sign. Okay.
If A is greater than 4,
then of the following, which will always have the least value? Why do we not be a brain?
So the least value among the 4.
So why don't we say A is 6 and just do it? Rather be a genius. That's what I would do.
Must be a genius.
Yeah, but okay, fine. There are 2 approaches to where into the approach, right? Well, first approach, study for the SAT and do the con questions. That's how you study for the SAT. Approach in this problem. You can either be a genius like Seth, or you could be an engineer type person like me, and just say, I'm just going to make A.
Okay, let me do an engineer type. Okay, well, so we're worrying about A's that are greater than 4.
A's that are greater than 4.
So 2 of these choices have A's in the numerators, and the other three choices have A's in the denominator. Well, when A gets bigger and bigger and bigger, the three top ones are going to always be smaller than the two bottom ones, because the two bottom ones will become humongous.
Right. Yeah.
So
now,
we have to worry about the three top ones. Okay, so A is large. A minus 1 compared with A, well, okay, A minus 1 is smaller, A is a little bit bigger, and A plus 1 is even bigger. And as you get bigger numbers in the denominator, the whole thing gets smaller.
Right.
Okay, so Joel picked the one that's this reasoning led me to.
Right.
Okay, so you just circled it.
So what I did is interesting. I started thinking that I would test it for A was 6, each one, and C. But then as I was doing it, I changed my approach midstream. I realized, wait a second, I can actually do this using theory. I can actually do it because I looked between B and C. C has to be smaller than B because the denominator is bigger. And then I looked at these and I crossed them out. This is crazy. If A is greater than 4, then if A is a million, of course this is not the least value. So I switched my approach midstream, which you have to be ready to do.
Yeah.
Wow. So as most of these reasoning questions, they look really scary. Even Seth said this is an interesting question, which can mean a pretty scary thing. But then in the end, it's actually not that bad if you think about it a little, right?
Yeah.
Yeah. Like a lot of things in math, right? They look pretty scary at first, but when you think about them, they're not that bad. But you definitely have to know, my God, you have to know that a big denominator, big number in a denominator makes the number smaller.
Yeah.
Right? Big denominator makes this whole thing. This number gets smaller when the denominator of a fraction gets bigger, as long as the signs are all positive. Yeah. So, okay. Well, I think we did that one.
But so this is for any A greater than 4.
So that basically A just has to be positive. But does it really matter? Doesn't A? Oh, A has to be greater than 1, right?
Yeah.
They could have said if A is greater than 1 and wouldn't have changed the answer, right? Wouldn't have.
Right. Except, what about the BCE, BCDs, and the A and B? No, about DZ. If A is 0, right, then D is 0, E is a quarter, and A is minus 4. It's too small.
No,
and B is infinity.
No, but but we're talking about A greater than 1, not 0.
Yeah. About A greater than simple. Strictly, A is if A is a little bit greater than 0, right? Well, you don't want to blow up on A, so say A is just a little bit greater than 1.
Right. Yeah, if A was a little bit greater
then
than
the
1.
top one is humongous. The B will be approximately 4. The C will be about 2, right? Smaller.
Oh, that's why A has to be
and if
greater than 4.
A is all but A is around is a little greater than 1, then D is going to be a quarter. The denominator.
That's why A has to be
yeah,
greater than 4.
yeah, right.
Oh, right. Yeah, look at that. Yeah. Oh, I see. So, yeah, there was a method to their madness.
Yes, there's a method to their madness.
Right. Oh, that's right, because you're dividing by 4. This is such a stupid answer, though, right?
If
Um,
A is 4, if A is 4, then D is 1,
yeah.
and E is 5/4,
Mm, right.
and A, B, and C are big.
Right. Right. Yeah.
Yeah.
Okay, sorry about that, everyone. Spoke too soon about a greater than one, where that would have been the same answer. But you're right. That was nasty. I didn't even look at this because this is such a dumb answer. Because
Yeah.
obviously there's no way this would be the minimum.
So the thing is that they're asking for what will always, if
Right.
A is greater than 4, what will always be the one with the least value.
Right. Yeah. And by the way, they underline the word least, which means they're screaming at you least values. You got to be careful. And if a
Yeah.
number's negative, it's a least value. It's you have to take that into consideration.
Yeah.
But there are no negative numbers here. Okay. So tomorrow is debatable whether we're meeting, but then we take the weekend off. But we'll be back
Yeah.
when we're back. And we will always refer back to this one because it has the instructions on how to get the digital SAT practice, which I think everyone should. Think it's a good idea for everyone, even if taking the regular, to start on that one because it's really the same stuff. Although there are some differences, which at some point we will talk about. There are some differences. It looks like complex numbers is not on the new test. Which is strange. We have to go over the tests. Seth and I have to look at them and make sure complex numbers aren't on there. But it's possible complex numbers aren't on there. But if you're taking the old test, like this year in 2023, you should know complex numbers. Okay, I guess that's it for today.
That's it. That's it.
Okay, so I guess we will stop the share, and we will stop the recording, and we'll see you next time we meet, which will be soon. Bye-bye.